Right. I'll just start here. Um, I recently watched this one, which is basically one problem, 24 programming
Video. In this
languages.
video,
And it has a fairly easy task here. So what you want to do is you want to sum all the how many negative numbers there are and how many positive numbers there are. And in the end, you want to compare them and see which one has the most. The easiest way to sort of demonstrate this would be to look at the C program. So here's the C program. It takes a pointer to numbers and the number of numbers, and they track the positive and negative numbers. And then after walking through all the numbers, we do this, compare and returning the maximum. So I was thinking that I'd just translate this into C3. So this is just in the same environment I use for developing the compiler, and I'm now going to use this configuration I have, which is basically compiling the compiler if needed, and then I do a compile run of whatever I have here, and some experimental settings here that you don't have to know about. It's just running this one, and it uses the standard library. But we don't really need the standard library for this. But I'm going to write that function, so we have the same thing as in C. Let's have like maximum count, but there's no need to have the pointers. We have a subarray slice of numbers, and now we want our positive and negative numbers, and since initialization is by default 0, these would be 0. I don't have this, and it's because of several reasons. It would be ambiguous in certain cases. So for here you have to declare them separately. Somewhat annoying maybe. Now instead of going through this using an if loop, we're just going to do a for each. So we're going to go for each, and I think everyone is familiar with that kind of syntax. And then instead of if and else if, I tend to use the extended switch. So this is the same thing as doing two comparisons. It is like under the covers, it's actually doing the same. Sorry, I should have that there. So it is doing if statements. So if this is positive, then we increase the positive, and there is an implicit break in C3, so we don't have to have a break. So you're just going to do this. And then I will import the standard math. So I have max function. So here we have max of positive, negative. Now I didn't test this and just wrote it for you. Let's try it out. So we have our main function, and to print something we want the standard IO library. And now let's pick something. We are going to say what is the maximum, and if we have something like maximum count. Oops, sorry. There we go. We have something like -1, -2, -1, 0, 0, 1. In this case, the negative numbers would be more than the positive numbers, and that number should be 2, right? There are 2. Let's just see what compilation errors I get. For some reason, starting this has gone really slow. So you get 2. So if I add one more here, I should get 3. This is so amazing. It's just like, this is not normally how it compiles. Right. And then, of course, I could add these. Doesn't change anything at this point, but if we do add more later on, sorry, I shouldn't mess with that until we get the answer. And let's do like 2, 3, 2, 5, 10, and now we get this. Okay, so 6, and there are 6 of them. So that seems to be correct. And we can also, I assume you'll see the other screen here, so you can see, like, here's the Go solution. Somewhat longer despite having this. Somewhat similar to the PHP solution in style, perhaps. Obviously here, Python solutions here, they're going to have different things, but I'm going to do one more thing though. How do we make this generic? So what we can do is, let's say this is a macro instead. Here now I don't specify the type, just saying this, and we have to have whatever this type is. We're going to have like the type of nums 0, right? And the same for this one. So in this case, we are basically inferring the types. And now I should be nice and then say, like, well, let's say this is a float slice, right? Let's see if there are any errors. I didn't test this, but so it should work. Yeah, and so, oh, sorry, I don't need to have these. I am being stupid. You still want that, so. Otherwise, I mean, it's completely necessary to do that. And now I get my cat to visit me on the desk here. You don't see her, but okay. So now we're probably in a better situation here. So you get 6. Now that was one, and I was thinking of actually giving another example. Now slightly different. Let's see if I got.
Welcome to a code report solution.
Yes, this is the one. And here instead, they want to sum over the. We start with a list of numbers. Then you want to sum these numbers. And it's a fairly straightforward C++ solution here. And what it does then is that you have a vector and then you have another vector. So to emulate this, I'm just going to bring in this. I'm going to have the generic list. And maybe I should need to drop the main here. So, and we want to call something called maximum wealth. Oh, sorry. Print max. Again, we have something max something. We can just this formats to whatever we want. So maximum wealth. and it's going to take some list that we have, and now we can generate different lists. Like we could imagine we had an array and of arrays. But for this example, I want to show that you have some tools for vectors. So let's say we want a generic list. And to do that, this particular list will have a length 3 vector. So let's call this one a vectorial list. And now I make a generic, and this is like this syntax will be familiar here. I mean the part where you parameterize. So this is the vector type. So this is a list containing vectors of length, vector types of length 3. And so when I do this, I want to first declare this list, and then I want to append elements to it, and let's pick those particular values that they had. So I picked like 1, 2, 3, and they had 5, 5, 5, and then finally node to pi here, I think 314. So we want to grab this one and we want to paste that into maximum wealth. And now we're going to write that function. And it's going to take a vectorial list. We can pass that by value now since we're not updating it. And it's not big because it's just going to have the pointer to the list. I think. Yeah, should have that. And now, what we want to do, we want to, for each, let's look at the C++, the naive C++ version, which is this one. So for each row we got, so this row is actually an int, we could type it if we wanted. We could have like this. Now we're not going to do that, but you have this, right? So, and for each of those, we want to have the max also. Like here's the max, we define that one, and it's going to be serial initialized as before. And now we want to sum over these elements. Oh, sorry, here in the row. So here we happen to have instead math a method applied on every int vector and if float vector as well. So that one is just sum. So we can do this, fmax. We're going to grab the maximum value. We can do this in several steps. So sum is then just row sum. And then we have like maximum is math max of sum and max. Right? And then we return the max. So this is it. But we can now, if we already know how this works, we can do it. I would just make it a bit shorter because there's no need to have this extra stuff. So now this should work. Let's run it. So we should get 15, right? Because that is the column, this is the row with the maximum. Yeah, so if we add 13 here, we should, or 33 here, we should get another result. 38, right? Why is it slow? Okay, anyway, so that works, but we can also do this as a macro. So let's say we do this as a macro. Now we don't know what the elements are. So it should be like, we should take the type of one element in this list. What's the underlying type here? and that would be this one, right? So the list has a row, and that one being the int of some length, at least one, and then that element, the type of that one, that should be like our max, because that is what sum is going to be. So now this should still work. Oh, sorry, we can just remove that one, otherwise this is just going to be wrong. And now it should work fully. And I can go somewhat further. I can just change this to float, of course. But we're going to see something else. So instead of now having a list, let's remove that one. Right, we'll remove this completely. And now instead of having that list, let's take an int list with, I don't know, two elements, and it has, let's initialize those to 1, 2, 3, and I don't know, 6, 7. So something like that. Oh, we have a variable sort list. Now this is like completely different, right? We could also do this. We infer the length. So that should be correct. 2 of the elements and so on. Let's see what happens. And gives 19, and that is exactly what this is, right? So we're done. So this here, obviously, even in C++, you could do this this generic thing. And here's the accumulator version of the same thing in C++. You have 17 versions where you use these, obviously. But this just happens to be really simple because there is sum and there is row, sum and product, and you can also XOR and or across these. So for sum, if it happens to be, like in this case, it just happens to be vector, something for the vectors, then you can do this. And maybe we'll add this for arrays, any type of arrays as well. Or at least integer arrays. In that case, you could do this for like much larger things than you would probably want to use integers for it. But there are other ways to kind of make this generic. But like this is a macro, so this is actually inline. And I had this idea that maybe we should have like this generic, a generic function, and that it will look at the type and then make one function for every type, like every combination of types here, which is the normal way you do it. But I've found that almost always when there is need for generic calculation, then that is often very tiny. Even like a sort would be really small, that perhaps the need to actually do it is like for with an explicit type is small. And in this case, we could always, create a explicit type that uses that macro. So if I want to do something and have a particular function, I could have like this and just take explicitly this list and then use the really short declaration syntax there is. So this one, well, let's see if I type that correctly. It looks not right, so I'm just going to see here. So now this becomes a concrete function, right? So, and this with this body actually inline into that function. And if like code size is a worry, then you can do that for those particular functions that would be used over and over again, and you can make, these baked sort of functions from the macros. So that's why I didn't add generic. You can do it manually like this if you really need it. And that is all I have for today. Thank you for watching.